Hey, I am Sven Ligenser, Master Student of Information Systems at the University of Münster. In this series on effective studying, I will equip you with all the information you need to make your studying more effective and fun. In this video, we continue with the practical topics variation and interleaving, mental models, and memory cues. Variation is the practice of diversifying the exercises you engage in on the level of an individual topic. Interleaving is the related practice of interleaving the practice of multiple topics, subjects, or skills. It includes switching a topic before each practice is complete. It is the practice that is most unintuitive for me personally. The reasoning behind it originates from the desirable difficulties. Remember the tenet that we should practice like we play. That is to keep the environment as similar as possible between learning and later applying what we have learned. And variation and interleaving are an inherent part of our everyday and work life. Take the example of a data scientist. The data is collected from various sources like APIs, databases, or web scraping. As every data set is different during exploratory data analysis, one needs to react to the findings and apply domain knowledge to reach good conclusions. And for the visualization of the data, one should take into account storytelling and the limits of human cognition. During the whole time, you need to program in different languages like Python, SQL, and other frameworks. We directly see the variation in the tasks to be performed and the interleaving of different technical and non-technical domains as it is typical for most jobs. As a side note, these practices are also found in the field of deep learning, which is concerned with building complex models to perform advanced reasoning tasks. The variability in the training instances is implemented by data augmentation, while the variability in concepts is achieved by shuffling the data and training for multiple epochs. These practices have empirically proven effects of improving the performance significantly, by resulting in better generalization. What are the advantages of variation and interleaving? In general, the versatility of the learning. This includes finding commonalities and differences between different problems, a broader understanding, a better assessment of context and selecting the right solution, and the transfer of learning between situations. Another benefit is that interleaving implements spacing, which we have already discussed in the last video, as being highly effective. The anti-pattern of these techniques is blocked practice, which does not yield these benefits and is sadly still widespread in school and university. There are some ways to intuitively implement variation and interleaving, which are first to vary the exercises. Depending on your course, you may have different options to do that. Redoing the exercises from your exercise sheets, where you could do the first exercise of every sheet, then the second, third, and so on. This way you have a greater variety in the topic. Further, usually old exams exist, which naturally give a good impression of the final exam and are a great learning setting. If these exercises are not enough yet, AI tools like ChatGPT are good at creating exercises and assessing your solutions. Prompting them with what you want to learn and possibly an old exercise or lecture content, and you are good to go. I recently tested this for myself and I was quite satisfied with the exercises. But, as always, reflect on the output of the LLMs and whether they make sense. Second, when you are learning with flashcards, it is essential that you shuffle them. Otherwise, you always have the same previous cards as context for the card, which will probably not be the case in the exam. Third, for interleaving, you can create a study plan for which topic to study when, as already discussed the last session on spacing, which needs a bit more foresight and organization. So here are my questions to you. How exactly do you want to implement variation and interleaving into your study routine? And do you want to create a study plan for the next examination phase? The upcoming topic, mental models, is one of my favorite ones, and one of supreme importance for us knowledge workers to be. Mental models are deeply entrenched and highly efficient skills or knowledge structures. They fuse interrelated concepts or a sequence of motor skills into a meaningful whole. They are a mental representation of key ideas, underlying principles, or rules from the external reality, which is the learning material. They arise and improve through effortful practice, either consciously or subconsciously. We can reference them and connect them with other mental models. We can apply and adapt them to various circumstances, but also need to realize the context where a mental model might not be working. Having them allows us to make sense of new information faster by putting it in a wider or new context. This can mean to learn an abstraction of a concrete idea. For example, numbers can be converted and transmitted into binary format. You can abstract that to all kind of information can be transmitted in binary format. Or grounding a more abstract idea into something concrete, as I will show you now with an example I experienced myself. The first time I heard of the mathematical operation convolution was in my 4th semester in the course Datenanalyse, in English data analysis. And please excuse my weird highlighting style back then. Back then, the convolution, which was introduced to us with the German term Faltung, was just a weird mathematical operation which seemed to somehow make sense in this specific context, but which I soon forgot. It took quite some time until it finally clicked for me when I watched the video "But What is a Convolution?" by 3Blue1Brown. I realized that Faltung is just the translation of convolution, and it actually has a quite intuitive visual intuition. Further, it is broadly applicable not only to compute the probability distribution of the sum of two independent random variables, but also for computing moving averages or for image processing. This anecdote is an example for how important it is to make the information relatable to ourselves by playing with the context and creating new associations. It is also an example for how connecting information is fun and rewarding. The syntax is the structure and wording of the information, while the semantics is its real-world meaning. And a crucial aspect of mental models is that the essence of something usually does not lie in the syntax. The precise wording is usually irrelevant. What matters is the understanding of the ideas behind the words. A direct implication is that mastering the wording of a lecture, for example by learning definitions by heart or the exact phrasing of a number of steps, is not the same as mastering the ideas behind it. This also has clear implications for lecture and exam design, but as we are currently the ones attending the lectures and taking the exams, I won't go deeper here. Nevertheless, terminology in a certain domain can be critical for effective communication and very helpful for remembering information and drawing associations, for example with Latin names in the field of medicine. So, when trying to understand something, focus on the semantics and on the key technical terms. To help you with creating a mental model of what a mental model is, here are some analogies and examples. We can see mental models as a kind of map, helping you to find the information relevant in a situation and associating information. You can also see mental models as a kind of framework, helping you to organize information and having a method for making sense of and classifying new information. An analogy from the field of computer science would be a code library, a structured collection of myriad useful solutions that we can call on at will from various circumstances. Stop the video now to think of some examples where you use mental models in your everyday life. They can include motor skills as well as cognitive skills. Some examples for motor skills can be driving a car, typing on a keyboard, hitting a ball with a racket, or performing an athletic exercise like a muscle-up. For cognitive skills, it is when you know a topic inside out and are able to reference it at will. For example, knowing the characteristics of a process or how parts of a complex system interact with each other. I also encourage you to make the material you consume your own. This includes to actively question the structure of the presented material and to restructure it as needed. Also are overarching multiple lecture sessions or even modules. The structure of the material in the lecture and the associations drawn may be the most logical and intuitive for the lecturer, but maybe not for you, as everybody thinks a bit differently and has an individual background. Also, our lecturer may be impacted by the curse of knowledge. Lastly, the presentation always has to be linear, slide after slide, word after word, while the connections between the topics are inherently non-linear. Maybe they are obvious to you by now, but what are the advantages of mental models? Having a mental model makes us more successful at selecting the right solution for unfamiliar problems, which is extremely important for knowledge workers. And I would argue that considering current trends, it becomes more and more relevant. While AI tools like ChatGPT can aid competently with many retrieval tasks, they will not be able to replace your mental models in the foreseeable future. At least this is my prediction. Further, they result in conceptual knowledge, which is the understanding of relationships of basic elements within a larger structure, instead of factual knowledge, which can be looked up easily most of the times nowadays. You can consciously create mental models for yourself by testing yourself on key concepts, where you should be able to define it in your own words and use it in appropriate contexts. The same also holds true for mathematical formulas. Try to explain them in your own words and in the context of where the formula is applied. Take this formula as an example. Don't explain it to yourself and others like this. So first we divide by capital N, then we sum up n terms, where I is our index, and no. Instead, the first part of the equation is a typical pattern to compute the mean. And every summand is computed as the deviation between two values, which is afterwards squared. This is why we also call it the mean squared error, short MSE. And it is a very common loss function in the field of machine learning, where it computes the squared deviations between our predictions and the labels. I agree this is a quite simple example, but it works in the same way for more complex formulas. I personally distill the information of each module in what I call the big picture. It is an overview of the information presented in the course, highlighting the interrelation of topics and general insights. Not all of it might be directly relevant for the exam, but it is highly relevant for me for my general understanding. As a motivation, how often have you been asked by a relative or a friend what a course is about and were not really able to communicate it clearly? For me, it certainly happened more than once, because I was too focused on the details and technical stuff that I could not set it in a context where it makes sense for a layperson. The big picture also serves as a polished reference for me for later. It is way more likely that I revisit the big picture than the lecture slides. And it serves as a conceptual entry point to retrieve more detailed knowledge. In the exam from memory, later maybe by looking it up. I refine it during the semester, adding new content to where it makes sense to me at that point. What follows is an example of a big picture created by me for a module on parallel programming. The structure of the topic is highly interconnected, and the lecturer came back to the same concepts from different angles multiple times. So, during the semester, the evolving big picture looked quite chaotic, with lots of unstructured connections like a degenerated mind map. The dark highlights were helping me to know which information I had already considered for my final big picture, which I created in preparation for the exam and which looked like this. I always use the same color scheme which I have presented in a previous video. So my questions to you. Which of your courses benefit most from creating mental models? Do you want to create big pictures like me, or do you think other methods are more efficient? How, if at all, can you effectively combine the big picture and retrieval? The last topic is memory cues, which is something with a familiar structure which we can link information to. Similarly to mental models, memory cues are a mental framework to store and recall information. The difference, though, is that for mental models the structure is found in the topic itself, while memory cues use an outside structure. The advantage of memory cues is that they facilitate the retention of huge amounts of information that have little to no connection. But they should only be used to organize what we have already learned. That means that understanding should always come first and remembering should come second. We should not abuse memory cues to skip the understanding phase, where we have the possibility to create a mental model. An example for a memory cue is the sentence, "Please do not throw sausage pizza away," which can help us to remember the 7 layers of the OC model. Memory cues can be implemented in various creative ways. The general rule is that the stranger something is, the better it sticks. Mnemonic devices associate information with something that is easier to remember, just like the visual image of throwing sausage pizza away from the previous slide. Memory palaces associate mental images of abstract material with a series of physical locations, as which you can choose any space familiar to you. The rationale behind this is that humans remember pictures more easily than words, and by mentally walking through our memory palace, the images we see can cue the abstract material we associated with them. It can also be used, for example, to outline a speech in a series of sketches. So my questions for you. Which of your courses benefit most from using memory cues? That is, that they depend more on learning by heart than by understanding and deducing information. What can be effective ways to come up with creative cues? And how can you commit them to memory? Let's summarize what you've learned today. Variation and interleaving are a critical aspect of our everyday life and improve the versatility of our learning. Mental models can arise unconsciously or be built consciously, and they help us to organize old and make sense of new information. Memory cues help in recalling large amounts of information that are only loosely connected. So, this was the last video of this 3-part series on effective studying. I hope you took some information away from it and maybe also some motivation to implement certain study strategies. I also hope you had fun listening to me, and yeah, until we see each other again, I wish you happy learning and goodbye.